This is the Databricks Data Engineer podcast. Most teams running a performance push on Databricks are tuning hard and shipping nothing, because they treat optimization as a long flat list of knobs to turn instead of a triage. By the end of this episode, you'll have a 99 one rule you can run on any Spark workload in about a minute, and you'll know why the staff engineer on the next team finishes the same kind of push in 2 afternoons while yours drags into week 3. Let's get into it. A scene you have probably been close to, if you have spent any time on a Databricks team that decided this is the quarter we get serious about cost. Your team is 3 weeks into a performance push. The Slack channel is full of tuning. Broadcast hints flying around in PRS. AQE flags toggled like Christmas lights. Partition counts retuned for the 3rd time. A half-finished caching rewrite that everyone has opinions about. The manager is asking gently when the gains are showing up in the bill. Meanwhile, on the next team, same kind of workload class, same scale, similar pipelines. There is a staff Databricks engineer over there who started their version of the push 2 days after yours. They finished theirs in 2 afternoons. Their bill dropped harder than yours. Their tuning PRS were short. They didn't open a single AQE ticket. You sit there and you think one of 2 things. Either this person is just smarter, or they are running a triage you have never been taught. It is the second one, and the gap is not Spark depth. The gap is what they decide is worth touching at all. There is a name for what they're doing, and once you have the name, you cannot unsee it. They are running a 99-1 rule. 90% of what your team calls optimization is cosmetic. 9% is real and converts effort into runtime or cost. 1% is the structural rewrite that makes all the rest of it irrelevant. The senior move is not better tuning. The senior move is ranking optimization work by outcome leverage, not by what's tunable. That is the frame. Cosmetic, real, structural. 3 buckets. Most engineers spend 90% of their time in the wrong one. Let me give you the simple version, because if I left you here, you'd already be running the rule better than 90% of the optimization work shipping into Databricks production right now. Think of it as a triage chart. Imagine a chart pinned next to your monitor with 3 columns. Cosmetic, real, structural. Every Spark workload you touch, every we're slow, Slack thread, every cost optimization doc someone shares around, you sort it into one of those 3 columns before you write a single line. The cosmetic column is the 90. Most config knobs nobody has measured. Broadcast hints sprinkled because someone's previous team did it. Microtuning a query that runs in 8 seconds. Repartitioning for the 3rd time without measuring the 2nd time. Catching a data frame that already gets read once. Almost every Stack Overflow answer that starts with, "Have you tried setting?" If you do these and the bill doesn't move, the workload was telling you the answer the whole time. They're pebbles. You can polish them all afternoon and the rock doesn't move. The real column is the 9. Skew handling. File size right sizing in your delta tables. Predicate pushdown that's actually getting pushed down, not just present in your code. Photon eligibility rewrites for the workload patterns that benefit. Cluster shape matching the actual workload, instead of inheriting whatever the previous engineer set up. These convert effort into outcomes, but they cost real work. They are not a flag flip. They are an investigation followed by a change. The structural column is the one. The thing that makes all the rest of it not matter. Changing the data model. Replacing a bad join pattern with a different read pattern entirely. Killing a workload that should not exist. Splitting one job that does 5 things into 5 jobs that each do one thing well. The structural change rarely shows up in tuning Slack channels because it doesn't look like tuning. It looks like rewriting. So the simple frame is, before you touch a knob, ask which column the ticket is in. If it's cosmetic, you don't touch it, no matter how easy it is. If it's real, you queue it. If it's structural, you slow down and pull people in. That's the rule. 99.1. Triage first, then tune. And if I left you here, you'd run a tighter performance push than most teams in 2026. But you wouldn't be senior on this yet, because the simple version is wrong in a way that gets you within about a quarter. Here's what flips it. The bucket a piece of work belongs to is not a property of the technique. It is a property of the technique applied to this workload, at this scale on this cluster shape with this read pattern. Let that land. That is the whole counter-thesis. The same change can be cosmetic on one workload and structural on the one running next to it. Let me show you. Caching. Caching a data frame is a textbook cosmetic move on most workloads. The cluster reads the file once. The file is cheap to read. You cached a thing that didn't need caching. You blew memory you needed for shuffle, and your stage time got slightly worse. Pebble. Now run the same caching on a workload that joins one mid-sized lookup table against a 1,000-row driver. In a notebook, the analytics team reruns 400 times a day, where the underlying file lives on a slow object store path with no cache fleet. Same code, same call. That cache is now a structural move. You stopped reading the same file 400 times. You changed the workload's economic profile. The ruck moved. The technique didn't change. The workload changed. The bucket flipped. Now run it the other way. Skew handling, salted joins, adaptive skew join. Most engineers I've watched put this in the real column reflexively, and on most workloads, it is. You see one task running for 40 minutes while the other 99 finished before lunch. You fix the skew, the bill drops, you go home. But here's the version where it's cosmetic. Same skew, same salted join, except the workload only runs once a week, and nobody notices when it's slow, and the downstream consumers don't have an SLA. Same fix, same complexity. The rug didn't move because there wasn't a rug there. And here's the version where it's structural. Same skew, but the skew is a symptom that one customer is responsible for 60% of the data, and the team has been pretending the data is uniform for 2 years. The fix is not a salt. The fix is a separate pipeline for that customer, and the realization that your data model has been lying to you. The technique was the same. What it pointed at was different. So the real frame is not 3 buckets that the technique lives in. It's 3 buckets that the technique times the workload lives in. Same change, 3 different rocks, depending on what's underneath. That is the move that breaks the simple model. Senior Databricks engineers don't carry a list of techniques sorted into buckets. They carry a triage they run on the workload itself. Now I can hear the objection forming, because every mid-level engineer who hears this throws the same one back. Sure, but I don't have the experience to know which bucket a workload is in. The senior knows because they've seen 1,000 pipelines. I haven't. That's the right question. And there are 2 answers. First answer, you don't need experience. You need 2 questions. I'm going to give you both. And you'll be faster at this triage by the end of the week than most of your team has been all year. Second answer, the whole point of the name tests is that they remove the experience tax. The senior isn't running a deeper version of the same triage you are. They're running a different triage. Once it has a name, you can run it too. Here are the 2 questions. Walk away with these. Write them on a sticky note. Run them on every performance ticket that lands on your desk for a month, and your judgment on Spark optimization will look 2 levels above where you actually are. The first one is the rock or pebble test. When the workload is performing badly, ask, if I made this technique perfect, how much of the runtime or cost actually goes away? Not how much of the stage, not how much of the query, the whole job, end to end. If the answer is 2% of the runtime, it's a pebble. Even if the technique is technically correct, even if it's a great PR, it is in the cosmetic bucket because the leverage is not there. Most config tuning fails this test the moment you ask it honestly. Most caching fails it. Most micro-broadcast hint work fails it. The rock or pebble test is what stops you from polishing. The second one is the leverage source test. When something is slow, ask, where in this workload does the time and the money actually live? One question. Open the Spark UI. Look at the longest stage. Look at the largest shuffle. Look at the most expensive scan. The cost is somewhere specific, and it is almost never spread evenly. Most Databricks workloads have one stage that costs more than the other 10 combined. Sometimes it's a join. Sometimes it's a scan over a poorly partitioned table. Sometimes it's a write that's producing 50,000 tiny files. Wherever the leverage lives, that is the only place the real bucket can hide. Everything outside it is cosmetic by construction. Doesn't matter how clever it is. 2 questions. Rock or pebble test. Leverage source test. Run them in that order on every workload before you touch a config. Let me make this concrete with a scenario you have probably been near or close to. A team I know was 3 months into a cost optimization initiative. They had cut their compute bill by about 12%. They were proud of it. They had a deck. The deck had 8 pages of config changes, a QE settings, shuffle partition counts, cluster runtime upgrades, Photon turned on for some workloads, each one a pebble that worked. A staff engineer joined the project for 1 week. She didn't open a single config file. She opened the cost dashboard, sorted by total spend. The top 3 workloads were 68% of the bill. The first one was a job that recomputed an entire historical aggregation every night, when the upstream had only changed for the last day. Structural. She rewrote it as an incremental delta merge. The bill on that workload dropped by 90%. The second one was a job that read the same lookup table from object storage twice in 2 different stages, because 2 different teams had each written a join against it without coordinating. Structural. She combined them into one read, broadcast it once, used it twice. The bill on that workload halved. The third one was a job that should not have existed at all. It was producing a feature table for a model that had been retired 6 months ago. Nobody was reading the output. Structural. She killed the job. 3 changes. 1 week. Bigger gain than 3 months of tuning. The team had been polishing pebbles in a quarry full of rocks they hadn't looked at. That is the real lesson at production scale. Not tuning is wrong. Tuning is fine in the right column. The real failure was that nobody had run the leverage source test before the 3 months of work started. The leverage was sitting in 3 jobs, in plain sight, on the cost dashboard. The team had spent its quarter polishing the workloads where the leverage wasn't. And there is a second move buried inside that, because every Databricks DE I've watched make this jump notices the same thing. The structural changes are usually visible from outside the code, from the cost dashboard, from the lineage graph, from the table sizes. The cosmetic changes are always inside the code, inside the config, inside the Spark submit args. So the senior heuristic is, before you open a notebook, look at the metadata. Where is the money? Where is the time? What runs that nobody reads? What runs every night that hasn't been touched in a year? The structural one is sitting up there, waiting for someone to look up from the keyboard. That's the move. That's the actual unlock. Now, walk back to your performance push, because we are going to close on the same scene we opened with, and you should see it differently. 3 weeks of broadcast hints, AQE flags, partition retuning, half-finished caching. Run the rock or pebble test on each one honestly. Most of them are pebbles, even the ones that are technically correct PRS. The bill doesn't move because the leverage was never there. The staff DE on the next team ran the leverage source test on the cost dashboard before they wrote a line. Found the rock, ranked the rocks, touched the top one, 2 afternoons, bigger gain. Not because they tuned harder, because they triaged first. It's not that they care more about cost than your team does. It's that they stopped using what's tunable as the input to the filter. They use "where is the leverage" as the input. Always, on every workload. Once you start running this rule yourself, two things happen. The first is you ship fewer tuning PRS, and the ones you do ship land harder. Your manager stops seeing config change PRS every Tuesday and starts seeing one structural rewrite per month with a real number attached. The shape of your work output changes. The second thing is harder to describe. The seniors on your team start treating you differently because they can tell from the outside who runs the triage and who polishes pebbles. The triage is legible. It shows up in your stand-up language. It shows up in your PR descriptions. You stop saying "I tuned the shuffle partitions" and start saying "I looked at the top 3 jobs by spend, and one of them was running a full recompute every night for no reason." That sentence is what staff sounds like. It is also what a staff interviewer is listening for when they ask you to walk through how you optimize the workload. That's what I've got for you today. Here's the homework question. Open your team's cost dashboard tomorrow morning, sort by spend, run the rock or pebble test on the top 3 workloads. Ask, if I made my best tuning technique perfect on this job, how much of its bill goes away? Then ask, where does the money in this job actually live? If the answer to the first question is almost none of it, and the answer to the second question is in a stage I haven't looked at in a quarter, you don't have a tuning problem. You have a triage problem, and now it's named. Most of the seniority game on Databricks performance work is just having names for the moves you were already half doing, and a column to put each move in before you start. 90% cosmetic, 9% real, 1% structural. Spend your quarter on the 1 and the 9, and watch how much of the 90 stops mattering. If this landed, send it to one engineer on your team who has been 3 weeks deep in a tuning push that hasn't moved the bill. They'll either argue with you or they'll quietly open the cost dashboard tomorrow morning. Either one is a win. See you next time.